So welcome to another segment of my physics O-level videos. We're still discussing under electricity. This time we are looking at some sample questions on how you can go about calculating. So these are some sample questions, coming from ECZ, exams. So let's try to see how you can actually get to calculate some of them. For example, it says study the circuit diagram. Then it says they have given us the 6 ohms resistor and the 4 ohms resistor. And if you remember, the 6 and the 4 ohms resistor are both arranged in parallel. And these are connected to a 12-volt battery. So it says calculate the effective resistance in the circuit. So they want us to find the total resistance in the circuit. So the solutions, therefore, remember what we said for resistor in parallel. If there are only two, you don't need to waste time. Let me call this one as being R1 and let me call this one R2. It is simply the product of the two resistors R1 multiplied by R2 then divided by the sum of R1 plus R2. So how is that going to be? It will be 6 multiplied by 4 divided by 6 plus 4. So 6 times 4 give us a 24 divided by 6 plus 4, that will give us 10. If you divide, that will give you a 2.4 ohms. So you don't need to actually waste a lot of time on that. Right, we can actually get to look at another question there. The B part, it says the current in the circuit. So we can apply Ohm's law. Remember, current is equal to voltage divided by resistor. So from Ohm's law, if you remember the triangle formula, we did say that voltage is equal to current times resistor. Therefore, if you want to get the current, it's simply the voltage divided by the resistance. That is what you need to remember. So in this case, we are simply talking about the total voltage. So the total voltage divided by the total resistor, that will give you the total current in the circuit. So what's the total voltage? They gave us it is 12 volts divided by the total resistor. It is what we have calculated as 2.4 ohms. So when you use your calculator, 12 divided by 2.4, and that is going to give me 5 amps. So meaning that is the current that is passing through the circuit. So that is how you can easily go about answering such questions. Well, let's look at another sample question that we do have. This is also coming from another ECZ exam. It was saying the figure below shows two pairs of resistors connected to a 6.0 volt battery. So they have given us a battery there, and you can see how these resistors are arranged. In my previous videos, I did show you how you can go about calculating the resistance in such a circuit when you have resistors arranged in such a manner. So therefore, the question there says calculate the resistance in the circuit between M and N. So they want us to find the total resistor. Remember what we said, these resistors are simply arranged in series. So you can reduce such a circuit by adding those resistors there. So when you add 3 plus 3, that will be a 6 ohms. You can also do the same, these are in series, then that is going to be now again a 6 ohms. So now when you reduce it like that, the two resistors now are arranged in what we are calling as being, they are actually arranged in parallel. So remember, we can say resistor total will be equal to, using this circuit, it will be 6 multiplied by 6 divided by 6 plus 6. So resistor total will be 36 divided by 6 plus 6 is a 12. So R total is going to give us a 3 ohms. That's what we mean. So that's the resistance. Alternatively, another one might have said, okay, I don't want to reduce like that. Well, it's possible you might also have calculated, if you call this one R1, this one R2, this one R3, and this one R4, I might have said, well, because these are in series and these are in parallel, I'll just say 1 over R total is equal to 1 over these two resistors. So resistor 1 plus resistor 2, that's what you could have said, plus 1 over, again, that would be R3 plus R4. That's okay. Again, you can use that. It will give us the same. It will be 1 over R total is equal to 1 over, when you add R1 plus R2, 3 plus 3 that's a 6 plus, again it will be 1 over, again when you add R3 and R4, that's a 6. So it would have been R total is equal to the common denominator there is a 6. 6 into 6 is 1, 1 times 1, 1 plus 6 into 6 is 1, 1 times 1 is a 1. So we are going to have 1 over R total is equal to 2 over 6. Remember, to get that, you can even use you can invent. When you invent, you just say R total. This goes up and that comes down. So it will be 6 divided by 2, which will give you 3 ohms resistor. But of course, I encourage you to use this one. First of all, reduce the circuit, then you can easily calculate it. It's the easiest way that you can use. Right, let's move on to the B part there, the current in the battery. So how do we get the current in the battery? That's the B part. Remember, current is equal to voltage times resistor according to Ohm's law. So it's the total voltage, which is 6.0 volts, and divided by the total resistor. In the previous one, we calculated 3 or 3.0 ohms. So when you divide that, that is going to give you 2 amps. That's the current in the battery. The C part says the power developed in the battery. Remember, we did say power is equal to voltage times current. So power is equal to, what's the voltage? It is 6.0 through the battery. And what is the current passing through the battery? Well, it will be the same as the total current, which is 2 amps. So power is equal to 6 times 2. That will give you 12 watts. So remember, that's a capital letter W there. So that's the way you can actually calculate this one. Now let's look at another one quickly. I want just to give you a quick question there so that you are able to see. We can put up another question that came in the exam. So this question, I will eliminate what is redundant. So I'll try just to put up, things that I deem necessary. So put up this type of an arrangement that they had. Put up such type of an arrangement that they had. They gave us the battery source was 12 volts. This was a 2 ohms resistor, and they gave us that was a 3 ohms resistor, and they gave us that was a 6 ohms resistor. Then here we had a switch there. So we had a switch, then this one was connected to a voltmeter. The 2 ohms resistor was connected to a voltmeter. And there, there was an ammeter. Remember, an ammeter measures current in the circuit. A voltmeter measures the voltage across the components that you are measuring. Now the question there was simply saying, if you can just put up a few questions there, calculate A, calculate the A. It was saying calculate the combined resistance. So calculate the combined resistance of the 2 ohms and 3 ohms resistor. So that's what they were telling you. Then B, it says calculate the total resistance, in the circuit, when the switch is closed. All right. Then C, it says the potential. We find the potential difference across the 2 ohms resistor. So the potential difference across the 2 ohms resistor. Then last but not the least, it was saying we calculate the total current in the circuit, when the switch is closed. So let's try to see how we can actually address such a question if you were given such a question as it came in the exam. So remember, there's a switch there. The switch is actually open. So meaning initially, if there's power passing through, there's current passing through, it means that it will not pass through this 6 ohms resistor. It will pass in that direction and go in that. So meaning this and that will be arranged in series if the circuit here is open. And that's what the first one there is actually asking us to do. It says calculate the combined resistance of the 2 and the 3 ohms resistor. So if that circuit is open, the 2 and the 3 ohms resistor are simply in series. And how do you find resistors in series? You just add them. So it will be the 2 ohms plus the 3 ohms. That will give me 5 ohms. So that is what we mean there. All right. Then B says calculate the total resistance in the circuit now when the switch is closed. So now they are saying when the switch is now closed. So meaning if we now close this switch there, what will be the total resistance? Well, if the switch is closed, it simply means the 3 and the 6 are now arranged in parallel, and as compared to the 2 which is now going to be in series. So how do you calculate the total resistor? Well, remember total resistor to be the resistor in series plus the resistors that are in parallel. Yeah, so let me just say those that are in parallel. So how is this going to be? It will be 2 plus the resistors in parallel. Because there are only 2, you multiply 3 times 6 divided by 3 plus 6 there. So how is this going to be? So R total will be 2 plus 3 times 6 is simply 18 divided by 3 plus 6, which is a 9. So resistor total will be equal to 2 plus 9 into 18 is a 2. So that will give us 4 ohms. That is the resistance when the switch is actually closed. So when you close that switch, the total resistance in the circuit is going to be 4 ohms. All right. Let's move on to C. It says we calculate the potential difference across the 2 ohms resistor. Now I want to tell you something. For you to calculate the potential difference across the 2 ohms resistor, it simply means that you need first of all to know the total current passing through the whole circuit. That is why the D part, if you look at it, it says calculate the total current in the circuit when the switch is closed. So I'll start by calculating first of all the total current, which will be voltage total divided by resistor total before I can deal with that. So the voltage total is 12 volts and the total resistance in the circuit is simply 4 ohms. So when you divide that, the total current there is simply 3 amps. So that's the final answer, the D part. But after calculating the total current, that's when we can calculate the potential difference passing across the 2 ohms resistor. Remember, the current for resistors that are arranged in series, the total current is the same as the current passing through them. So we can say potential difference represented by the voltage is equal to current times resistor applying Ohm's law. So what's the current? It is 3 amps. And what's the value of that resistor? It's a 2 ohms resistor. Therefore, the potential difference will simply give us 6 volts. So this is what you needed to do. Please watch out for more videos as we look at how to calculate the cost of electrical energy in a circuit. See you in my next video.